Hello everyone. Let's talk about branched alkanes. This is Professor Dr. Vainath from Dr. Mekazi Institute of Chemistry, University of St. John's. So what are iso compounds? Now isobutane, neopentane, isobutane are all branched chain alkanes. What are isoisomers? Now isoisomer is simply a carbon atom that is belonging to a parent chain that is connected to three other carbon atoms like this here. This is parent chain that is connected to three other carbon atoms. Now this is an example of isobutane. Here you can see isobutane. Okay, so this is the 3D structure of isobutane. Now here simply we can see different carbon atoms that are connected to each other with these bonds, right, that are in the form of sticks. Now you can resemble the structure with this structure also. The 3D structure is resembling with that structure also. That is, this is the same methyl group over here with the 3 hydrogen atoms. This is the carbon with the hydrogen CH, whereas this is this hydrocarbon with the 3 hydrogens. This is the same methyl group, and of course this is this methyl group that is pointing towards the reader, right? This is the strong wedge that is pointing towards us, towards the viewers, towards the readers, whereas there are the bonds that are away from the reader. That is this one, right? This is the 3D structure. So this is isobutane. Okay, so I hope you like the structure of isobutane. It can be rotated like this, like this, like this, right? So this is isobutane. It's beautiful and it's quite, easy to understand how they look like, the 3D structures, right? And now, as I mentioned earlier, at the end of these sticks there are hydrogen atoms attached, which I will soon arrange and I will soon show you how they look like, right? So this is it. You can see the 3D structure of isobutane. Okay, now let's begin with another structure, that is isopentane. CH3, CH, CH2, CH3 and CH3. These are all branched chain alkanes. Okay, so here you can see the structure. Here the structure resembles the 3D structure, the 3-dimensional structure. It resembles with the structure over here, that is this carbon, CH methyl carbon with the 3 hydrogens. This is this methyl group, right? This one. Then of course CH, this is CH. Then of course it is bonded to again a methyl group with the 3 hydrogens, one projecting towards the viewer and the 2 that are away from the viewer. This is this methyl group, this one. And then of course we'll come to this one, CH2, this group. This is this group, carbon with 2 hydrogens. And then of course the methyl group, that is this one. So that's it. You can see here this figure resembles the structure that is drawn on the paper, right? This is isopentane. So this is again a branch structure. Fine. So this is again, you can see the carbon atom that are bonded to this carbon and this carbon at one and the same time, right? So this is the 3D structure of isopentane, and it resembles with the structure that is drawn over there on the paper. We can simply match the structures easily. So now let's see neopentane, that is carbon atom that is connected to 4 methyl groups. This again, here you can see the carbon atom that is connected to first methyl group, the second one at the back, the right one, and this one, right? It is connected to 4 methyl groups. It's called neopentane, right? So in neopentane, the middle carbon atom, that is this one, is connected to 4 carbon atoms. Yes, we can see here it's connected to 4 carbon atoms. 1, 2, 3 and 4. These are also called constitutional isomers. Now these all compounds are called constitutional isomers, that is having same molecular formula, but of course difference in the connectivities, the way they are connected, right here. So Isobutane, isobutane, and neopentane are examples of common names. They are also termed as trivial, referring to what? Of course, the historical names, as common names are difficult to explain the larger, huge molecules or huge compounds or complicated compounds that are common, are also, you can say, that contain isomers. So these are all examples of constitutional isomers, that is isobutane, neopentane, and isobutane. These are all the branched chain structures. And here, this is a beautiful example of a neopentane. Here you can simply see the bonds that are projecting towards us, right? And the bonds that are away from the viewers, right? These are on the paper, they are represented by dashed lines, whereas the ones that are pointed towards the reader are always represented by strong wedges. That is this one, they are pointing on the, in the books you will find them, they are with the strong wedge bonds, like this one. I can make it here, the strong wedge, if you forgot, that is the strong wedged bonds, right? This is a strong wedge bond, this one. Okay, I'll show you in a minute. This is a strong wedged bond, right? That is pointing towards the reader, whereas these are the ones that are away from the reader. The ones that are away from the reader, these are represented by dash bonds, like this. These ones that are away from the reader. So this is an example, again, a 3D example of a neopentane. You can see how beautifully they are arranged, how they are different in their connectivities, right? The way they are connected, and that's why they are called branched alkanes. And this is an example of a branched alkane, and it's called neopentane. Is a beautiful compound. And I want to show you the structure more nicely, more clearly. You can see and you can match it with the structure on the paper. Methyl group, carbon, first methyl group, second methyl group, and third methyl group, and of course the fourth methyl group that is on the top. So this is an example of neopentane. I hope you can see it and you can match it. The 3D structure and the structure on the paper. This is all stereochemistry, the chemistry of space, right? The 3D structures, the three-dimensional structures of different compounds, right? And right now we are talking about the branched alkanes. This is how they are arranged, and when I will add the hydrogens at the end of these sticks, you will find them more beautiful. Hopefully I will get the hydrogens and then I will show you again how they look like. So this is the manual animation of neopentane compound. I hope you like these structures, you like these videos. Today I will put them again in front of you so that you can see them. The second one, and of course the third one, which I have shown, right? Today I've explained you people these three branched alkanes. I hope you have enjoyed learning these compounds, how they are arranged, how they have difference in their connectivities. This one. And of course this one. Yeah. So lovely, so beautiful. So stereochemistry is all, you know, very interesting. If you understand how the atoms are arranged, in a three-dimensional way. I hope you enjoyed this video and you will learn it, and you will now use molecular models. You can make the molecular models. I have an idea, and you can find different ideas on YouTube with the matchsticks. You can join the matchsticks with the Play-Doh, and you can make molecular models of by yourself, and you can study if you are really interested in stereochemistry, because stereochemistry you are going to learn deeply when you are going to deal with in final year organic chemistry, and in the other higher levels you need to know the different connectivities, how they are connected. So these are all the ball and stick models of branched alkanes: the isobutane, isoopentane, and neopentane. Okay, that's all for today. Thank you very much. See you next time with something nice, something more interesting, and something more, or the connectivity of this whole video. Let's see what I have planned. Thank you very much.